That'll be $11.40, sir. And there you go. What the heck are you doing? That's way too expensive. Relax, the customers can't see the prices. No one will ever find out. You really gotta stop. I have to undercharge our customers to make the profits look similar. You're gonna get us both in trouble. Oh my gosh, you two, why can't we just charge the actual prices for the products? You're overreacting. Everything will be just fine. But I have to get home. It's getting late. This just doesn't make sense. We sold about $12,500 worth of products. I made about $12,350. So in this transaction, Alan sold 2 candy bars, 3 bags of chips, and 1 soda. With our prices, which is $1.15 for candy bars, $2.15 for chips, and $2.30 for soda. This should be $11.05. But Alan charged $11.40, and somehow we're still under our projected sales metrics. So let's look at bets now. From the sale, we sold 1 candy bar, 1 bag of chips, and 3 sodas for $9.75. But that should have cost $10.20. So that means Beth's probably the reason why our profits are down. And Chris, you charged $7.90 for 1 candy bar, 1 bag of chips, and 2 sodas. Which seems right. So that means we have at least 1 employee who's charging the right amount, which is, I don't know. If we decide that X is equal to candy, Y is equal to chips, and Z is the soda, we can make a system of equations with the last three transactions that Alan made. And now we can solve. If we solve the system of equations, we can figure out how much he's charging. So we can start by taking this top equation, bring it down here, and then also multiplying this equation down here by -2. Then adding those 2 equations together to get 3y minus 9z is equal to -28.2. And then we can divide both sides by -3 to get y plus 3z is equal to 9.40. We can do something similar over here by taking the second equation and then multiplying the third equation by -3. When we add that together, we get -7y minus 11z is equal to -41.8. So after we have those 2 equations, we can make y plus 3z equals 9.4 into 7y plus 21z equals 65.80 by multiplying by 7. And this is useful because we can add the 2 equations together now and cancel out the y. So we have 10z is equal to $24. So Z, or the soda, must cost $2.40. Now that we know this, we can plug $2.40 into our y plus 3z equals 9.4 equation. And we distribute the 3 to the 2.4 to get y plus 7.20 equals 9.40. And then by moving the 7.20 to the other side, by subtracting, we get y is equal to 2.20. Now that we have both of those, now that we know what y and z are, we can solve for x with one of our first 3 equations. So we can plug in our variables for y and z. We can multiply out, and we can combine our like terms, and then move the constants to the other side to get 2x equal to 12.40 and x equal to 1.20. Now we can compare this with the actual prices to see that for most of the products, Alan raised the price by 5 cents, but for the soda, he raised the price by 10 cents. To double check our work, we can rearrange this bottom equation and turn it into x equals 19.80 minus 3y minus 5z. This way we can have x in terms of y and z, so we can plug that into an equation for x, and then when we distribute out, we only have a constant, then y terms and z terms in here. So when we combine like terms, we can again get an equation with two. And we can do the same thing over here, moving the 19.8 minus 3y minus 5z in for x. Then we can get that just to y and z. And then we can solve for y and z to get negative 7y minus 11z is equal to 41.8. Now that we have these equations, we can solve the top one for y to get y is equal to 9.40 minus 3z. Then we can take this bottom equation and plug in that equation for y, or 9.40 minus 3z, into this equation. So now we only have one variable in this equation. Now that we only have one variable, we can combine the like terms, and we can see that 21z minus 11z, or 10z, is equal to $24. So that z must be equal to $2.4, or $2.40. We can plug $2.40 into our $9.40 minus 3z equals y to get that 940 minus 720 is equal to y, or y is equal to $2.20. Now that we have both y and z, we can take this equation, which we started with at the beginning, and plug in the variables so we can get a number for x, which is 1.20. We can also arrange bets, sales into a system of equations, but this time, instead of using substitution and elimination, we're going to use matrices to solve this. And so we're going to set it up in an augmented matrix. And then we can start using row reduction, with just the first step is to multiply the top row by -4 and add it to the second row, which would make the second row 0 to -11, and then on the other side would be -28.4. After this, we can multiply the top row by -2 and add it to the bottom row, giving us 0, 0, -4, and then -8.80. After that, we can divide the bottom row by -4 to get 0, 0, 1, and then 2.20. So now we know that z is equal to 2.20, or she's charging $2.20 for the soda. Now we can add 11 times row 3 to row 2, which will give us 0, -2, 0, and then -4.20 on the middle row. After dividing by -2, we have 0, 1, 0, and then 2.10 for the second row, which means that the y, or in this case, the bag of chips, is worth $2.10. After this, we can add -1 times row 2 and -3 times row 3 to row 1, which will give us 1, 0, 0, and then 1.05, which means that one candy bar is worth $1.05. To check our answer, we can plug this matrix, the 3x3, into a calculator and raise it to the -first power to find the inverse of the function, and then we can multiply that by the right side of our augmented matrix, and that will give us our answers for the correct prices in a matrix. Comparing this to the actual prices, we can see that she's charging $10 more for candy, $5 more for chips, and $10 more than soda than what she's supposed to. At this company, if you're charging the wrong price for your products, we use the formula 0.01 times 1.5 to the x, where x is however many dollars you were off in your calculations, the absolute value of that, and whatever the y value of that is, that's how much you get fined for paying the wrong amount. Alan was off by $20.15, which means that if you either plug 20.15 into our exponential equation, or you graph it and find the point of intersection, Alan owes $35.34. Beth was a little more off. She was off by $24.15 in the last month. And so she has to pay a fine of $178.90. Because of their lying about the prices, they will not only get fired from this company, but they will also get fined between $35 for Alan and $180 for Beth.